I just wanted to tell you, if any of our speakers sets a poll during hers or his lecture, you can answer the questions on matchabout.com. Please don't forget to network with people on the app. And now, without further ado, I would like to welcome very good chess player and best agile coach in UK, Marcello Duarte.
Hello. Can you hear me at the back? Cool. So let's talk about eager design. Are you eager to learn about eager design? I'm Marcello. I work for a company in the energy sector called OVO Energy, based in the UK. They do like sustainable energy. So I want to leave a better future for my kids. And I code for open source as well. So my day job is lean/agile coaching, but I can't keep my hands off code. So this tool is a BDD-flavored unit testing tool to help you build. Has anyone here come in contact with PhpSpec already, or any users? No? Cool. I also got a badge as the best agile coach of the UK. I'm not the best agile coach of the UK, but I get to say I'm the best agile coach of the UK because I've been given a badge. And I tweet, so if you're interested in following the banter, follow me on tweet _MD to make it easy for you to include me in conversations. 3 letters only. So agile is lazy. And when I say agile is lazy, I don't mean that in a bad way. I mean that agile takes, if you're following an agile mindset, you probably defer in decisions until the last responsible minute. That's a part of the mindset of agile. If you can make decisions about things later on and include those on your design, or include those on your product, you delay so that you learn more about the risks and the product, and you incorporate that learning. And also you be very slim on your iterations and get some feedback before you go into a direction or another direction. I say that because the word lazy and the word eager, they seem to be kind of opposing, right? So agile is lazy. Here he comes to an agile conference talking about something eager. We're both aiming at the same thing. Software development is a people game, is a social game. It's people who buy the software, people who use it, decide to use it or not, people who work with each other to build that software. And if we get the people variable wrong, we get the software wrong, right? So it doesn't matter if the 0 and 1s are all in place. If the X and Y's, chromosomes, male, female, are not aligned, software is not going to be effective. Do you agree with that? Cool. We live in an age of excess. We've got, so much at our hands. We can do amazing things. Our computers today, from when, like, if you go back in 1985, when you see the personal computers arriving at homes of people, my kids can do so much more today than I could do when I was a kid. And there's so much available for you to play with, frameworks and languages. And it's very easy for us to overdo anything because so much is available to us. And if you look at the way we approach solving problems in Agile, we take an approach which is usually an outside-in approach. You guys using something like test-driven development, BDD? Okay, so you've got your conversations, you write automated tests, and those things will then drive the decisions of how you go about developing software. And then you go and sit down and you follow all those frameworks. You use a framework that is available. There are many frameworks available there. And they're amazing because they make your work much efficient. You can go very fast about building things. Eager design is about addressing accidental complexity. Sometimes just by following the rabbit hole, just by following what the frameworks leaves us available, we overdo things because we use those frameworks and we use those mental models, I'm talking technical frameworks, but also the conversations, the workshops that we use. We use them every single iteration. We do that every single time. And we don't always question what is it that what we're using that for, and because we don't start with the goal, we start with the framework. That's what they are. They're a framework for you to then just keep the flowing that way. So eager design takes the approach of subtraction. What is it that I can take out this time? Can I stop and think? Is there anything that I can take off of this whole process, of this design process, of the agile process, or anything else? If you go back the beginning of last century, this gentleman, so his name is, the correct name is that one there with the two things, it says Toyota. You know who I'm talking about, Mr. Toyota? So he created a company called Toyota. But he was so fascinated with waste that he changed his name to save some neon lights on the outside of his shop. So subtraction to the maximum. And then, there's optimization and flow, thinking of streamline production so that we can get to the customer and deliver value the quickest and the most efficient way, effective way. I came across this book. I was looking into subtraction. I came across Matthew's books, and I thought it was interesting that the principles that he has in this book, they kind of guides you through coming across a process of design that incorporates tips to keep it simple, but at the same time constraining you to find creative new ways of solving your problems. And I want to cover some of I think I'm out of the range now. I have to go back a bit. So the principles will be in a book, but I'm just going to talk for a couple of them that really motivated this talk. The first one I want to talk about is creativity thrives under intelligent constraints. So for 10 years of my life, I worked in training, coding on my own time, but I was training a software organization. And one of the things that we do is the Code Club. And the Code Club was a place where I locked the software developers for an hour, and I gave them a problem to solve. Not only I gave them a problem to solve, I would constrain the way that they could solve that problem. So here's a problem. Don't write a solution for that the way you usually write a solution for that. You're not allowed to do this, you're not allowed to do this, and you have to do this, and you have to do this. And then I start observing the reaction in the characteristics of the design that they produce. So they would have to write code in a ways they were not comfortable with, and they will produce, but this is an hour of their week, by the way, where after that they could go back to work and do whatever they want to do. But the solutions that came out was really inspiring. I was very much heavily reading about functional programming at the time. I've always been very keen on the ideas of domain-driven design. So I was using some of the principles and forcing the developers to write software that follows some of the principles, which I was constraining in the workshops. So I came up and I discovered accidentally a few principles that will lead you to write software in a different way, beginning from the inside out. So if you want to write software in an inside-out approach, as opposed to the outside-in approach, which is the usual way of developing software, which works for most of the problems that we have, what if you don't know where you're heading with your solution. You have no idea about the algorithm. You have never solved that problem before. And going in a TDD or going with a framework leads you to write a lot of software that is completely misled by the design of the process that you adopted. So that was interesting. And I just captured those principles, and now I want to talk about those principles. I want to share them with you. So these are 4 principles that I want to talk about and go over a little bit and explain to you how did that fit into that process. The first one is jumping to the problem worth solving. I tried this one first on the process level. I had this team that I was working on an internal application. I couldn't do this in a whole organization at the time because it's too risky. But I've got a team of people who are working an internal application for the company, and I told them, look, I'm not going to give you a product backlog anymore. I'm not going to give you any requirements anymore. I'm going to give you 1 or 2 goals, and I'm going to time box I'm going to discuss with you what's the time box for achieving those goals, and then we're going to have 1 ceremony only, which is a demo every day at the end of the day. So I replaced the product backlog by a goal backlog, and we select together what would be the most effective goals for every iteration. And the only ceremony we had is a demo at the end of the day where they got a little bit of feedback to say, is that okay if we solve the problem this way? And that feedback was tailoring the design on a daily basis. So the team, instead of planning and designing and analyzing things and the sprint planning, they are doing that on a little pieces every day. And they had to decide, what is the thing that we really need to solve? What is the core of the problem that we have here, that if we solve that, we can get across and achieve our goal by the end of this time box? So they hit on the problem we're solving head on, straight. Of course, this doesn't apply to everything. You can't take this idea and now use in every single software project. Some projects require deeper analysis. You need to understand the emotional journey of your users. You need to have a deeper understanding of the user experience. So you need to question a few things before sitting down and spending a day to then deliver a demo at the end of that day. But I thought it was an interesting way of approaching software development, so we tried that, and it was really effective for that particular problem. The second here is eagerly replacing primitives with types. We a developer group here. This is a technical talk. Are we okay, comfortable with? Okay, there'll be a lot of code. So after some point, if you feel like this is not for you, feel free to get up. So replacing primitives with types is about identifying early on what is it that are the types of my software, eagerly, value objects, invariables, and make everything very, very solid right from the beginning, because you're going to have to, if you're going to start inside out, this is an important rule, because you're making sure that whatever model you have in that particular macro space is going to fit, and you're not going to be repeating yourself as you go outside. The third principle is composing your application. I didn't do this. It's moving by itself. Move forward. Move. It lost control. Okay, I regained. I am the master of my command. So the third one is composing the algebra inside out. So this is about making sure that you have something called local reasoning in your design. So you can reason about the design of your little pieces of code in a way that you can reason without worrying what's coming outside. You do that by isolating all the effects around around your code. So this is going to be interesting for you to see in code as well. And the last one is avoiding mutable state. So your state can be added later when you are outside of these local reasoning components. So let's look into the normal way of developing. It's outside in. You probably, if you are a developer, you're probably using something like this. It's a model view controller or a TDD cycle or a layered architecture of some kind. Here are some more of those hexagonal architectures, event-driven reads and write separation. Yeah, you're doing something of this sort? If you are a developer, you should be doing something like this. There are some articles that I found very useful on how to do a good outside in. So if you want to get into different approaches for approaching outside in, I like modeling by example. And there's also this by the guys who created a Cucumber framework. So what they do is that they start on the outside by looking at the domain, and then they connect with the UI. Okay, so by following the outside in, you definitely will go slower. You're going to go slower to get to the core of your problem. You have to develop everything to the point where you have the core of your algorithm, the problem that you solve. Sometimes, by going in that route, you are led to a different design, you are led to a different solution, or you see, okay, I have to step back because this is not going in the right direction. You tend to have a solution that might be more complex than what it needs to be, and this will restrict the amount of composability that you have in the system because it's driven by the outside. When you build your models to be composable on its own, it's more likely that they can be composed on a larger scale. Of course, you can address composability from the outside in as well if you're using an approach like TDD and Monkeist approach that can also lead you to good composability. So when are you supposed to try eager design when you're writing some code? So if you think about 4 layers of 4 different kinds of projects, and the ones that you do all the time, and the ones that you've done before, but they're not so simple, the ones that you have not done before, and the ones that you have not done before and no one in your company or nowhere in the world has done before, you have no idea how to approach it. So for these ones here, outside in, they're kind of hand in glove, and they're kind of most of the problems that we have on a daily basis. And things that you have really not done before, they're a bit more rare, and they're really good for eager design. And if you have no idea, then you can try eager design or not on those as well. So let me tell you a story about a chess application that we built in the organization that I worked for. And so someone said, we need to have a tournament. Oh, okay, we are developers. If you have to have a company tournament, we need to write an application for the tournament. And 1 year passed and there was no tournament because nobody wrote an application. But all we needed is really something like, people play with each other. Make sure that you have, we're not going to play with the same person. You're going to play with someone else in every round. And when you play with the other person, he's going to play white one time, and then you're going to play black one time. So this looks very simple, but there's something very interesting about this problem of creating the schedule for a chess tournament, which is, how do you go about creating these permutations? So it's very simple. On this particular one, you only have 4 players, but if you have like 8 players, what is the algorithm for permuting, making all these players play with each other, and make sure that when you create each of the schedule, you have a unique round that doesn't repeat ever? And there's something very interesting. There are a few algorithms out there that address this problem. So the application would just add players, generate the schedule, enter the results, and see the ranking. Can you see which one is the most complex one? Which ones are the trivials? And what is the eager point? Sorry, did you say? Schedule. These are trivial, these are eager design. Cool. So let's see how we went about doing this. So you got some domain rules here. The players will play with every other player. Players cannot play twice in the same round. Every player must play in every round, and players must play twice with another player. So I thought, okay, this is interesting. The real algorithm here is how do I convert a list of things into a list of unique pairs? So this is a problem. And I looked up online, looked up for an algorithm, and I couldn't find an algorithm, and I couldn't bother solving it. So I talked to my friend, and then he said, let me think. And then he went away and thought about the problem. And the next day, he went to the whiteboard, and he showed it to me. So you got a list of things. What you do is that you curve this around like that, and then you slice it. So you got this, the pairs are like here, black and white, so you have all the sides here. And once you do this, what you do next is that you rotate this thing to the right, like this. You move the H to where the B is, and then everything clockwise like that. And if you do this enough time as the number of players that you have, then you've got your schedule. The next thing you need to do is to randomize the list in the end. So this was the algorithm, okay? So if you just start with the algorithm, you solve the algorithm, now writing the application is really, really easy. Just have rounds now, you can play chess. So you got the first set of rounds, you just reverse them, and everybody who was black are now white, and everybody who was white is now black, and you just randomize the whole thing, and then you get a schedule. Shuffling. Just to have it more unique. Okay. Now, breaking is an important part of breaking through. Messing up with things, it's important. So if you're doing things in a TDD way and evolving your code, you can do that if you know what you're going to do next, or if the design can lead you to the next step. But sometimes, if it's something that you have not done before, Kent Beck talks about that in the Extreme Programming book. He divides the three things that can be addressed with knowledge and design. He says some things can come from intuition directly, so you have an intuition because you've done this so many times. Other things can come from just a little bit beyond the intuition because you've done other things that are similar, but you can do that one because of your experience. And there's a third level that is beyond intuition that you cannot reach that level. I worked for a company in the early 2000s where it was a mobile development company. They did not know how to send messages over the air. I was doing that for a year, so I arrived there at the company, and after 1 week, they've got the screenshot of the logo being sent to the employees of the company, and the CEO was very, very happy, like a child. Hey, I can do this. They were trying to do that for 6 months, and I arrived there, and very quickly, after 1 week, I was able to do that because I had the experience. But for me to have the experience, I have to break things apart. So jumping to the problem we're solving, I wrote a library, Funky, which is like a functional library that PHP developers can play with if they want to do some functional programming. So I'm just going to show a solution for this implementation of this algorithm in a functional style in PHP. So we've got a list, like we have a list of players, and there are these 4 functions: head, tail, init, and last. Head will, leave exactly what the slide is showing you. Head, you take the first element of the list. Tail, get everything else. Init, get everything except the last one, and last will get you the last one. So you can then, looking at that algorithm, imagine that you have a list, playing with my repo. I will then just make sure that it works, get the head, get the last, get the init of the tail, and in one line I have the entire algorithm that I need for my application. So that is, I put that in a function, I call that a shift. And I just add some tests at this point and I find out some problems, and then I fix that in the code. And then now I'm starting to go inside out. Once I have the shift, I will now split the pairs. So I get the players and then split at the half of the length. It gives me a pair with two lists. And I put these sides, one for the black and one for the whites. So I can assign them to different tuples. And here I can zip them together to create a round. So now I have created one round. I just need to repeat the problem again. Repeat the solution again and every round. So to get all the rounds, I will start from the inside out. I would do a count of the rounds and then make sure that it's not going to be more than the number of players minus 1. Then I shift the players around to move 1 square forward, and then I just call the function again. And doing this recursively, I'm avoiding keeping the state anywhere, just the fourth principle there. So then the schedule will be the concatenation of the rounds and then inverse rounds. If I just randomize that, I have a random schedule. Now, if I look at the primitives and I replace them with types, I would have a very strong, the type systems helping me build invariance within my application. So this is a statement by a gentleman who invented the term object-oriented programming. He said, "My math background made me realize that each object could have several algebras associated with it, and there could be families of these, and that this would be very, very useful." So using the algebra would be very, very useful. So he coined the term genericity for dealing with generics behavior in a quasi-algebraic form. So if you don't know who he is Alan Kay. He didn't like the way Simula did inheritance, so he decided to leave inheritance out of Smalltalk for a little while until he understood better. So Alan Kay's stronger influence was something called ML, a language written in 1973. And ML has a type of generic implementation, which is some sort of polymorphism in a functional level. But the word polymorphism was not invented at the time. So this making types generics allows you to create a type that can create other types. So you can use like higher kind of types. This is really good for creating types like this. So a list of players, and you can have a pair of players. So the angle brackets. So you've got list of rounds, lists of match. And it's interesting that this comes from functional programming, not object-oriented programming. And it was later that it was added to object-oriented programming. An interesting talk about making everything reflect to values is given by Rich Hickey. He's the founder, the creator of Clojure, the language Clojure. If you think about all the programs that you write, they can be boiled down to the fundamental values and fundamental types. Like you can think about most of the classes that you write as maps of key values, the key being of a very specific basic type and a value being another specific base type. It's by writing those things as classes, what you're making is that you're making your code not being as portable, because when you move from language to language, you have to rewrite all those things again. But if you're using the type system itself, then your application becomes very, very portable. So that's the idea. So if you're using very simple types and then at the nuclear level, aliasing those types to create your own types, you are able to have a much more portable systems when you are scaling up. So shifting again. Now I'm using the types, the players, all of these types alias based on the fundamental types again. So you see the types on the signatures are all now within the domain. So now composing the algebra inside out is about how do you then add state, how do you add a database, how do you add all of the things that, the interaction with the user, all these useful things that programs have if you're starting from the inside out. So think about every application that you write, something that has an input and an output. In this case, you got players, and you end up with the schedule. But to get to the schedule, you have to get the rounds. And to get the rounds, you need to get the round. So your program is just a transformation from type to type. And what defines the transformation from type to type are domain rules defined against those types. And as I showed before, the types, the domain rules I've got are those of the applications, a very simple application. You can read about this method that I'm going to show you now on the book by Debashish Ghosh. It's functional and reactive domain model. It's a technique that he uses to abstract all the effects of your application, and other techniques are shown in this book as well. So the rich domain model would be, combining state and behavior at the same time, and the lean domain models will be having these units of behaviors, which are the functions, and immutable states in between, and having the laws, making sure that the invariants are kept. So let's have an example. For example, the rewarding lawyer accounts for coffee drinkers. You have a green card, a gold card, or a closed card, and you earn stars every time you drink some coffee. And there are a number of things that you can do in this service as well. So let's think about the verbs here, which is earning a star and claiming a drink. And this will be the reward service. And the verbs there will be commands. Okay, so I'm just creating an abstraction. Now I moved into a different language, which is a more functional language, just for the sake of this example. So you've got the abstraction, and then you have, okay, what are the primitives of the data that I need in here to earn a star and to claim a star? To earn a star, I need my account number, and I need the order, and then by the end of this, I'll have my accounts updated. If I am claiming a star, I'm going to need my account number. I'm also going to need to say what are the drinks that I want to claim, and get back the account updated and an order updated. So now how do I compose my algebra inside out? First thing you want to think about is, will I ever get my accounts back? Is there any possibilities of errors? So you start thinking of types that you can add on top of that abstraction. So this is a very simple situation where you have an either, but it could be an either means that you can either have an error or an account. In the other case, you can have an error or your account and order. But you can abstract all the effects, such as persisting to disks database, by adding an abstraction at the higher level, saying that your whole service will be abstracted on the effect. So if you add that to all of your services, and you notice that all the return types are now changed so that it has an F prepending it. And if I want to add another thing to another effect to my services, I can just use another abstraction. And the resulting code is always going to look like this. It's always going to look like locality. I make an order, I make another order, I take a refund, I take another order, and I can claim a drink, and that should work. If I want to make this program run, I can pass the repository at the end, because I'm abstracting the repository out. I can now make my code asynchronous as well, just by adding another thing to my outer layer, saying that instead of using a repository, I'm now using a future, and the resulting code, surprisingly, would look the same. just adding a separate abstractions on the outer code. So if you look at another application, this is just so we have an example. Have you played this game? If you have not played this game, I don't recommend you install this application ever, because you're not going to stop playing it. But I had to explain a little bit of the game so you understand what the code's going to look like. So the goal here is to swipe. So the way you play this is you swipe in one direction, right, left, up, or down, and the numbers will merge together. And the more numbers they only merge if you are the same. For example, you can merge the 2 with the 2 here, and you can merge the 2 with the 2 here. And you want them to merge so you get bigger numbers. So you want that 2 and 2 to become a 4, and then eventually an 8 and a 16. So you can merge with the other 16 and then merge with the 32. So what is the eager point of this? What is the problem that if you solve that problem, you solve the entire application? Any guess? You just need to learn how to merge 2 cells. If you merge 2 cells, you can then replicate that into merging 4 cells. And then you can merge, if you can merge 4 cells, you can merge 4 cells in any direction. So you're just repeating your problem and outscaling it. So finding the eager point and going straight into solving that problem will save you a lot in terms of scaling out that solution, merging 2 cells. So the cells can be of the same value, different value. Right-hand side can be empty. So in these 3 cases, just code that. The first case is that the cells have the same different value. Then the second is where another is empty, and the other one is where they both have different values. So once you do that, the swipe is just very, very simple. And then you can just swipe in different directions after this, and you achieve that. So I talked about how the principles of eager design can help you avoid accidental complexity by hitting on the problems from the inside out. But you can only do that if you are very disciplined with the way you approach the design from the inside out. And you should only do that if you're solving a problem that you don't know how to solve it. So you're playing with the algorithm, and then you find in the algorithmic solution, and then you're able to scale that solution from the inside out. In the process of doing that, you have to follow the 4 principles, which is jump into the problem we're solving, eagerly replacing primitives with types, composing your algebra inside out, and avoid mutable state. I am Marcello. I work for OVO. I do open source work sometimes. And I got some badge from Agile competition. And I tweet MD on Twitter. Thank you. What's the protocol here? Do I just leave, or is there questions? Do you have questions? Huh? Yeah. Yeah.
Based on your experience, do you see that it's a problem that new developers that are being educated, the new generation, are getting very into the libraries, like Lego kind of programming, or?
Yeah, would you like to repeat so that people can hear at the back?
So like the question is, do you think the new generations, the developers or software people or engineers coming out of colleges, do you think they are getting very addicted to the pre-prepared stuff for them and coding that way instead of like thinking as you do?
If I think this is a problem of the new generation, no, I think that's always been there in software, that we might sometimes overdo and over-engineer things. I just think that I might have stumbled into some techniques to kind of avoid that in a case where solving that problem would help you solve a larger problem. right? And yes, that's also a message for how can we solve the problem with the minimum effort in general. So we do that by aiming at goals rather than aiming at abstract requirements, list of requirements. So that's there as well. Does that help? Is that? Are there any other questions? Oh, there's a question there.
Those daily demos, when do you set the goal?
When do you set the goal?
Yeah.
So you should always have goals prior to start an iteration. So there should be goals on a list of goals. That's the rule.
So how do you adapt? So in the morning you set the goal for
No,
the
you
day?
have to have goals prior to start working.
Okay.
Okay? So the goal generation is an ongoing thing, but the team should have goals set for them before they start an iteration. Say your iteration is 1 week. During that week, goals are being set for the future iterations if you already don't have goals. So you should always capture goals, but your goals should reflect the need of the business, which changes all the time. Right? So if you're not having a list of things that you have to implement, you're observing what are the things that we need to achieve, and how software can address that.
So if I understood you correctly, so you go, have a problem to solve, set the goals, get in. As new goals emerge from the current work, you just add them to the something that's backlog-ish,
Yeah.
and then team picks the next goal that they want to achieve, and then just moving through the list.
So you discuss with the team, so can you achieve, how many goals can you achieve in your iteration? The team picks the goals and say, okay, we have a timing box for 2 weeks, we're going to use 2 weeks to solve these goals. And they come back with and work interactively with the business.
Thanks.
Oh, there's a big clock here, so there's 3 minutes more if you still have a question. Okay, thank you very much.